Good afternoon, Jan.
Michael, good afternoon.
We're back.
That's a long time ago.
Yeah, I know. How have you been?
I've been okay. I've been okay. Busy with a lot of things, but feeling well. So that's the
Excellent.
most important.
Yeah.
And you went off on a holiday?
Yes, indeed. Yeah. Jenny and I went to Cozumel last week. Just spent the whole week on the beach in an all-inclusive resort. Did a little bit of
Okay.
snorkeling, but not much
You-
else.
And you managed to do that without your computer.
Yes, yes. That was the most important thing. Yep. It's like, oh, you know
Yeah.
what? This just won't fit in my bag. Have to leave it at home. Oh well.
I don't believe that.
Yeah. It was really
Uh,
good.
okay. That's a resort far from your place, or?
Yeah, so I'm in the Dallas area in Texas. Cozumel is in it's just off the coast of Mexico, um, and took about 3 hours to fly there, and yeah, then we just kind of stayed on the island the whole time. Um, in fact, we stayed in the resort most of the time. And yeah, just ventured out on one day so Jenny's cruised through that area a number of times, and I never happened to be on the cruise when she's stopped at Cozumel, and she's like, "There's a place here I want to take you." So we took a cab out to the pier and,
Mm.
and ate at Pancho's backyard, and then did a bit of shopping and then came back.
But so that's even more to the south,
Yes.
even warmer.
Yes, which oddly enough, it was very mild. So yeah, even though we're closer to the equator, it just I guess being right there on the ocean, um, it was well, I'm trying to translate into Celsius in my head, but in Fahrenheit in the mid 80s. So um,
Mm.
nice and
Yeah, Fahrenheit
nice and
doesn't
mild.
say much to me. No, here it has been the last 2 weeks been raining, raining, raining. And we are not used to it anymore because the past 2 years there was not enough water,
Hmm.
so we were not allowed to give water to the plants, to wash the car.
Hmm.
Uh, a good excuse to leave everything dirty.
Yeah.
But so now
Yeah.
it started raining and
Hmm.
it didn't stop anymore. Okay.
Yeah, so you see your neighbor and their car's all filthy. Oh, drought. And then yeah, yeah, a year later, car's still dirty. Oh, drought. No, the drought's over. No, this is for the next drought. I'm saving up.
No, I think now we will be allowed to wash the car again.
Hmm.
But it rained quite good, so the car is clean.
Yeah.
No, it isn't.
Yeah,
It
yeah.
isn't.
Rain clean is a different kind of clean.
Yeah, good. I saw that there were some messages coming in from David, I think.
Yes, yeah, yeah. David Schwartz at Improving, he heads up yeah, the project that we're using Jinaga for a client.
Mm.
We are wrapping up the first phase of that project, so they're going to do a bit of testing with what they've built so far, and then probably around the August timeframe, they're planning on spinning back up um, and starting phase two. Um,
Mm.
so yeah, we've
But I mean,
learned
it, it
quite a
goes
lot.
the, it goes already into production with the customer, or it's just internal testing?
This is just internal testing at this point.
Okay.
So yeah, yeah, we have released a replicator to the production environment so that we could actually put it on iPads and do some testing. And this is an internal application, so it's for um, representatives that are in their stores, and so they're going to be um, putting it on some iPads, trying it out in select stores, and getting some feedback during that process.
Okay, so that's not too bad.
Yeah, yeah,
That will be
not
the
bad
real
at all.
testing.
Yes, indeed.
But it was about a confusion between the local facts and replicated facts, or
Yeah, yeah. A really important thing for this particular client was to keep the local data store as clean as possible.
Mhm.
So so they asked for things such as soon as you, and this is in-store order taking, as soon as you submit an order and the order is on the server, the replicator, then we want you to delete it from the local store, and um, and it's like that's we can do something, but we can't do exactly that. Um, so yeah, it was a whole bunch of well, if what if we um, uh, what if we roll the database once a day? What if so all these different negotiations of how we can accomplish their goals, um, and so in addition to keeping the local data store as small as possible, they wanted to minimize the amount of traffic as much as possible. And that led to all the great optimizations about switching to the graph protocol, um, and so yeah, that's really good lessons learned, really good outcome from that. And another another one of those was the separation between local only facts and replicated facts. So the idea is, excuse me, they wanted to. Ooh, there we go. They wanted to use the local store only while they're taking the order, and then then you might go back and edit and get things ready. And then once it's ready, then you push the button, and at that point, that's the only point at which it says sends it to the replicator. And furthermore, we want it to send just the subset that actually needs to be sent, not all the history of all the edits that happened.
Mhm.
So, um, so that was a combination of modeling the data to work that way and giving the application developer the way to distinguish between saving locally and saving in a replicated way.
What's the reason to wait with sending things until your file is finished?
Um,
Because for the customer, that should be completely transparent. They shouldn't know about it.
yeah, uh, so I I think that it should be okay to do it the way that you're saying. Just keep it going. That way, that's the default way that Jinaga has worked all this time. Um, but the clients we just had a different opinion about that, and so ultimately the answer is, as the Jinaga library developer, I want the application developer to make that decision. I don't want it to be my opinion. But so all that said, let me take the position of the client here. Um, so they want to minimize the amount and the frequency of traffic from their stores. So maybe there's some some condition with their networks that they want to make sure that it's not very chatty. So one of the things that the development team has been doing while developing and testing the application is keeping a network monitor open so they can see all the network traffic. And so the concept of chattiness of how frequently it's connecting and how much information it's sending, that was just an ongoing top of mind. It's like I did a thing and now I'm testing it and I'm looking over here and I see it scroll. Say, oh, okay, too chatty. and then they make a change. So so I don't believe that there was a specific number. Okay, we have to make sure that we use only this much bandwidth versus that much. But it was more of a sense of an aesthetic, I guess.
Yeah. Because in Android, okay, that can make the difference between waking up the radio every few seconds or waking up, for example, every 5 minutes. And so you conserve a lot of battery
Yeah, there you go.
by doing that.
Mm-hmm.
But then on the other side, they want to keep the local database as small as possible,
Yeah.
which is a little bit, yeah, is not, it's a little bit contradictorious.
Yeah. Yeah.
Yeah. Um, because in the end, you cannot work offline anymore.
Yeah. So yeah, that trade-off. That's a thing that the developer team, development team needs to be able to make. And so yeah, two. I would say two values, I guess, of the Jinaga project that are important there. Number one, the developer should be in control of making those decisions. So give them the tools to make those decisions. And number two, which is probably actually more important, so maybe this should be number one, is to be correct, to have behavior that is provably correct. Don't give the developer so much control that they can go into the incorrect lane. So yeah, that's where this differs from just
there.
yeah.
Yeah.
Yeah, like the bag of tools. Like, okay, you've got SQLite, you've got HTTP client, go for it. Well, with that bag of tools, you can be incorrect. But yeah, so I give you a more constrained bag of tools that says, okay, I'm making some guarantees. One of those guarantees is when you call Jinaga client.fact, and it's the task resolves. So you await that, and now as soon as you're done and no exception has been thrown, the guarantee is that that fact is persisted. That eventually, assuming that the device is able to connect at some point in the future, eventually that data will be shared. And so yeah, there are things inside of the library like it checks to see, are you using a persistent store or are you using an in-memory store? If you're persistent, then get it into persistence and then return to the user, kick off the sync in the background. But if you are talking to an in-memory store, then it has to connect to the replicator and send that fact, get a positive affirmation from the replicator that it received the fact, and then it can resolve that task.
Okay. To be absolutely sure that the data has been stored.
Yeah.
No, I had some customer in the past who really didn't want to have a lot of local data,
Mm-hmm.
but that's more a question of they don't want their data to leak into hands of others, like for example the whole customer database.
Yes.
Some customers, they don't care, they say put it all on,
Mm-hmm.
on the laptop, and when the technician needs to select a customer, he has everything.
Mm-hmm.
Another customer says no, just send the data for the devices on which the technician has to work, send that to the laptop,
Mm-hmm.
and not more than that. And once the intervention is finished, keep it, for example, for another 10 days on the laptop. If ever he discovers that he did something wrong, that he can redo or change the report, but after that it has to disappear.
Uh-huh.
But so that's a different opinion on the customer side.
Right. Yeah, and that's a perfect example. I do want to support that opinion. Yes.
Yeah. But you could achieve it in two ways. Delete the data locally, or like you usually do, encrypt it locally so that it is not accessible anymore.
Yes. Yeah, yeah. And that brings up another tension that happened on this team here. is that um, they they didn't want the users to have to authenticate. The user should just be able to pick up a device, take an order, submit it. Um, but um, but they also wanted that level of security. Things like on-device encryption. Things like only being able to fetch the information that this device needs. Uh, and and so without some kind of security principle, without some kind of authenticated user or device, then you can't. There's no place to have a public key, and there's no place to put the private key, and so therefore you can't run authorization rules. You can't run the encryption. That all starts from the security principle. Um,
Mhm.
so um, so my recommendation, my recommended solution to the team was to, instead of a user principal, a user logging into the device, have the device itself be the principal. Um, and there was a bit of confusion around. Well, if this device is lost and we need to provision another device, we want this one to have the same identity as that other one. And it's like, okay, it's going to have a different public key, but that could be the first layer, and then there could be another layer that says, oh, some provisioning that happens. Some central authority says, I provision this physical device to be this logical device. So we could solve that. That would be in the model, and that's kind of the central thesis. So the the use case that you just described, there would have to be seams in the model to be able to talk about those particular things. So deleted after 10 days. So there would have to be some seam in the model that counts days. So I would use the
Yeah.
period pattern at the day granularity, and I would keep 10 periods. Um, and so that way you go to the next period, now you've just shifted your window. And then I would also have it roll the local database once a day. So it's got yesterday's data, rolls the database, and now it fetches 10 periods into the current one. So that 11th day is now just in the background, and then you roll again. Maybe you set your window to 9 if you really want to make sure that it's only on the device for 10 days. But if you want the technician to be able to access it for 10 days, then it has to be on
Mhm.
device for 11 days.
Yeah.
Yeah, so it's got to be
Mhm.
that overlap window, and that's assuming that you can actually connect every day. If you can't connect during a day, then the roll the database method has to fail. Um, Correctness first. You can't say, "Oh, okay, I'm going to delete data," even though it hasn't
Mhm.
made it to the replicator. Um, so yeah, I think the upshot is you need to decide what your security rules are, what your position is going to be, and build that into the model, and then you can express the rules given authorization, distribution rules, user principles, and device principles. Rolling the database at different times, and on-device encryption. So yeah, all of these things are, and that's the final thing is that all of these things are planned and in the backlog, and I know exactly how I'm going to accomplish them. Not all of these things are yet implemented in Jinaga.net or in
Mhm.
the replicator or in Jinaga.js, and so another part of this was prioritizing the backlog. So it's like, okay, you want to accomplish that. I need you to build the model this way. Meanwhile, I'll go and prioritize this feature, and I'll work on this in Jinaga. Um,
Mhm.
so that was the ongoing negotiation.
But there you see again the advantage of having a library like Jinaga. If once you go into practical cases, there are so many conditions and so many different approaches.
Mm-hmm.
Um, if you have to reinvent all that and come to a correct way of working, it's almost impossible.
Yeah.
So with Jinaga, you can build everything into the library, all these scenarios, and have something that works.
Mm-hmm.
But if you have to do that as an individual for every project,
Yes.
it is not possible.
Yes. Yeah, and I am I'm starting to see the level of of expertise that's necessary in order to build a truly successful Jinaga application. Um, so I've been I've been trying to aim for this world where anybody who's got skill in Excel can build an app, and so these kinds of decisions, these are not necessarily programming decisions, but you do need to understand the the rules, with which in which you're living. So you need to understand historical modeling, and then you also need to understand what does it mean to roll the database. How do you use the period pattern and rolling the database and on-device encryption in combination to achieve a certain result. Um, so yeah, I think there's
The
one way
whole
we can
new
get
world
started.
that you have
Yeah.
to learn.
But then, you can graduate to another world. Okay, I am an expert that knows how to solve these problems. And then when I think this is my favorite part of it, is that when a client comes to you and says, I want, I want these two things. I want the the on-device data to be as small as possible, and I want it to be offline capable, and I want to minimize the amount of traffic. And okay, these three things are in tension, and I can tell you exactly how they are in tension. Um, and there is no way in Jinaga to express something that goes too far. That actually says, okay, promises to give you all three of these things, and then fails in some edge case.
Mm.
So the library itself pushes back.
Well, but to get back to the security on the device and the user, my experience is that you need to know the user of the device, but the device itself as well. Because by knowing the user, you know which data you have to download to the device, and which data that user can access. But on the other hand, like you said, the user might lose its device, or he might have multiple devices in use. He might have running the application on his laptop, on his Android, on his iPhone at the same time.
Yeah,
Um,
and third
and
possibility is like in this scenario, they have devices that are just there for an entire group of users to use as needed. So it's like if we've
okay,
got
so
these two
so
iPads in the store.
the data is common to everybody then.
Yes, some subset of data has to be common to everybody. Others has to be specific to this user. I mean, ultimately, they wanted this order to be. Well, no, actually, that's not true. One of my earlier implementation or earlier ideas about what they wanted was, this order is specific to this user, but you don't want that user to log in. So how do you know? Um, uh, but no, they actually do want another representative to be able to pick up the iPad and continue an order that somebody else started. They want that convenience. But yeah, now you have to to weigh that. Okay, so that means that from a security position, that means I have access to all the orders in this in this office, this store. So if that's part of your security position, then the concept of store needs to be in your model so that you can express that security role. And then at some level, store has to participate in that chain of trust. So so in this case, I think the ultimate idea would be that you provision devices to stores. So a store is part of the model, device is part of the model, and that device has a public key, so there's a private key somewhere. In the case of device, the private key's on device. Um, if the device is capable of encrypting. So in the case of something as powerful as an iPad, yep, it's on device. It encrypts and it signs. And then you've got provisioning, which is a fact that is authorized only by some central authority. So somebody at a keyboard somewhere is saying, okay, I've shipped this device to to that store. So open up the device and somehow say this is your identifier, or share your identifier over here. So now I know the public key, and now you create that fact. You say that device is associated with that store, and now part of your security rule for distributing data to that device and also for accepting orders from that device would include this join from store through this provisioning fact over to the device itself. So now when you see that signature from that device, you recognize it's provisioned in this store, and therefore it's allowed to say this order.
Okay.
Yeah.
Mm-hmm. Now, I had a similar requirement in one of my old softwares, which is actually technicians working at customer places. So a technician goes to a certain customer, he starts working, and for one or the other reason, one of his colleagues has to take over his work. That could be, for example, 10 days later, technician left the company, so another one is taking over, or because he's sick and one of his colleagues, for whatever reason. What I did there, all the technicians have access to all the customer files, all the ongoing interventions. But if they open an intervention of somebody else, they become the owner. So every technician can see his list of unfinished work. But so at that moment, it appears in the new technician's list of unfinished work. And that works quite well.
Yeah.
Once they know that if they touch the information, they become the owner. That's a bit scaring for them. So if they don't need to go in it, they don't do it, because there will be a trace.
Yeah. I can see. Yeah. So yeah. At first, when you said owner, I was thinking that the idea of ownership helps with synchronization. It's like, oh, we assume that there's only one owner. Therefore, if we see information coming in from two different places, we accept the information from the owner. But then, you said ownership is really about your to-do list, the pending work.
But anyway, before somebody else can take it over, the information has to be synchronized already. Yeah, because you start something at your customer, before I can take over that file, it has to be synchronized to my device. And if I go access your file, then I become the owner, and I have the responsibility for that file to finish that intervention. And it will disappear from your list.
Okay, I think this is actually another great example of so you've expressed a certain desire for a certain solution. Jinaga cannot implement that specific desire, but it can implement something else. And I think the motivation behind that is what it can implement. So start with why can't Jinaga do that? So you have something in your model that represents that that this person is the owner versus that person is the owner. The first issue is you cannot say in historical modeling that this person is the owner and nobody else. It doesn't have any kind of exclusive lock, capability. There's no way to express that in a historical model, because there's no way to express that in a distributed system. So so yeah, that's the thing that it can't truly do. What you would do is you would have a fact that says I'm transferring ownership from this person to this person, and then you would have this history of transfer of ownership, and now when you look on on any particular device or any particular replica, you would be able to look at that history and see who you believe is the current owner right now. But somebody else might have new facts that you don't know about. And that chain of transfer of ownership may branch. You might have a transfer that occurs in parallel somewhere else. So that means that you could have a transfer to two different people, and now you have information that tells you that two people are owners. So it's not a
Yep.
conflict. You know that two people are owners, but you want that to be part of the model.
Mm.
So there's that, and then there's the idea of you can't transfer ownership until you've replicated the data. Well, the transfer of ownership happens from the other person's perspective. They open, and so now they become the owner. So that's happening on their device. But
Yeah.
you know, on your first device, you
But
haven't replicated.
that,
So
yeah, that has to go back to the first device.
yeah,
I hope my customers are not listening
yeah,
because they will say, Jan, something is wrong with your software.
yeah.
No, actually, 1 hour before this video started, that customer called me that software is running since 2003 or 2004, but okay, still changing.
Uh huh.
And the guy who's responsible for the technical stuff, he said, there is one of the rights I don't have, and that's the right to, he can delete his own interventions. If they are not finished,
Mm-hmm.
they can delete them. Once an intervention is finished, you cannot delete them. But I cannot delete them for my colleagues.
Mm-hmm.
And if there is, for example, a colleague who leaves the company
Mm.
and the intervention is not finished, he should be able to delete it. But then I go look into my software, that right has never been there, so I have
Ah.
to implement it.
Yeah. 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 That would
Do you
make
see?
sense. And
After 20 years, um, they discover that they need a new functionality.
well, hey, that's
Uh,
good. People are are using it and say, I
but
need this.
they are using it,
Yeah.
definitely. No,
Excellent.
but there you see that indeed software which is working so long
Mm-hmm.
still is fundamentally flawed.
Yeah. 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 It's making two
Um,
assumptions
uh,
there that
yeah,
truly cannot be implemented in a distributed
mm,
system that where
yeah,
so I should qualify can't be implemented in a distributed system. There are algorithms like Paxos and like the distributed transaction coordinator that do implement this, but they have very strict requirements on the on the nodes. They have to know how many nodes there are, and those nodes have to be available. And then it can implement this locking behavior. But we're in a world where you don't know how many devices there are. They come and go, um, and
mm.
uh, and yeah, they're not all going
And
to be
where the
available at the same
devices
time.
are not available all the time.
Yeah, yeah. So under those conditions, there is no algorithm that implements what
Mm,
what you're promising there. So
yeah.
so Jinaga doesn't allow you to express that promise, and so therefore it forces you into promises that it can keep, and I think those promises satisfy the underlying idea of what you want. So um, so I think actually in this case ownership is serving two different roles. It's helping with the synchronization that you're going to accept information from the owner and not from non-owners. Um, but then also the task list, the to-do list.
Mm,
Um, if we only promise the second one, then that means that two people on two different devices might see the same things on their to-do list because they each think that they're the owner. But eventually, the person whose ownership has been taken away will no longer see those tasks on their list. So I think that satisfies the intent. Um,
mm,
but yeah, people are are used to thinking in terms of real time. It's like, I did this here, and so therefore that disappears there. And you just can't promise that.
Because you might have the two technicians who work on the same file, both have as owner, because they are both, one of them is offline, and then you can get a very serious conflict.
Yeah. 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 So, so yeah, if there's something else in the system that prevents conflicts, then you don't need the ownership idea. So if you built it on top of conflict-free replicated data types, then you could say conflicts don't occur. Sometimes you do have to redefine conflict, though. So, so yeah, in Git, we call two branches that can't merge without intervention. We call that a conflict. But Git is actually a conflict-free replicated data type. From the definition of conflict for CRDT, there is no conflict. Once all nodes, once all replicas, all machines, everybody pulls the same branches. Once everybody's done a pull, they both see that there are two branches, and so they are in agreement. No conflict. It's just we use the word conflict to mean now I can't resolve this into something that looks like it was linear history. So in this case, the idea of an intervention having two different owners, you define as a conflict, but if you redefine that word to just mean that everybody agrees that there are two owners, then there is no conflict, and now you have to build into the system how does the user or some other part of the system, how does it resolve that situation? And then, just like with other parts of the CRDT, once that resolution makes it out, it everybody is in agreement that it was resolved. So, yeah, sometimes you have to redefine your terms, but you can only express the things that Jinaga can promise.
But now that I start thinking about that software, because actually once the technician finishes the intervention, the results, the report is automatically, or he can choose to automatically have it sent to the customer.
So a customer might be confused to get two different reports.
No, because the report is sent by the server.
Okay.
And so the first finished report that comes in will be sent by the server. The server increments a status.
Yep.
And so once it's sent, it's sent. So it might be the wrong one.
Yeah. Okay. So in order to implement that, so this is like the end of chapter 2 of the book, I think, is where I talked about this kind of stuff. In order to implement that, you have to move outside of the historical model. You have to have a static model that's connected to it, because the static model can do those locking type of behaviors. It can have uniqueness constraints. It can have a single state for an intervention, and so you can deploy a static model on a server and have it sit right next to that replicator. So now the replicator learns, hey, there's a completion. Fire off an event to now this static model that looks in its database and says, okay, they look up that order. What's the current state of that order? Looking at it off the historical model, looking in its own static model, and then making that decision. And so it should also put that decision back on the historical model. So it should say, I sent the report to the client, and now that becomes a fact. And then now everybody can eventually learn which one was reported. And then you could actually write a query that looks for that situation where there were two completion facts, only one of them got sent to the client. And now you can you can investigate.
So actually, by luck, I implemented that on the server,
Okay, yeah, yeah.
and so it goes well. Um,
Hmm.
but yeah, once you start thinking about the logic behind it,
Yeah.
why didn't Jinaga? Why was there no Jinaga in 2003?
Yes,
Yeah.
there was historical modeling, but just barely, and it was just in a little blue notebook in my bag, um, and it at that point it still had some problems. Like I was still using lists instead of sets. Once I said, oh, it's all sets. Oh, the math works. Um, yeah, yeah. So this is something that kind of occurred to me when working with the improving team on this project. Is that at first I was kind of worried that okay, I'm not the one designing the model, and when I see the model that they're designing, it's like I wouldn't have chosen that way. So I was like, uh, yeah, how sensitive is this system to a well-designed model versus if somebody makes a mistake, how badly can it go? Um, and more importantly, does the system does the library and replicators, does it kind of guide you into correcting it? And so one thing that I kind of learned from this is because it won't let you express things that it can't do, um, then you can't make a really big mistake. You can't make a mistake that will violate one of its guarantees. Um, and then um, so the sorts of things, the sorts of tension that we were running into was I want to express this, but I can't. And so I've figured out how to change the model so that I can. What do you think about this change? And that led to some really good conversations that said, okay, that was an improvement in the model. It had to improve in order for you to get what you wanted out of it. And now these are some of the consequences of that change. So I could kind of forewarn them of the next thing that they would run into because they made that decision. So um, so I think what I've come away with is that it actually is possible for somebody to kind of feel their way through, kind of bump into the guardrails of Jinaga to take um, the Rich Hickey visualization. Do you know Rich Hickey's talk about complexity? And
No.
yeah, it's a great talk. I think actually it's in the history in our general channel. I was talking with Zora about Rich Hickey, um, but uh, uh, but during this talk he's talking about test-driven development and so how with test-driven development you can set up these tests, these guardrails that will keep you on the road. So just imagine somebody driving to the store bouncing off the guardrails. Oh, it's a good thing I had that guardrail, otherwise I'd driven right off the road. It's a funny visualization. Um, it's flawed, but it's funny.
Mm.
Anyway, so so yeah, in this case, I think that the things that you can express are actually are those kinds of guardrails. Maybe they're more like bumpers, inflatable bumpers, is just kind of guiding you back. But uh, but because you can't express something that is incorrect, it actually does kind of guide you into uh, an alternate form of expression. Once you get there, you know that it's still correct. Um, so, yeah, I'm still going to be putting out the education on how to do this. Get you from the level of just hey, let's build our first app to the level of okay, let's express our security rules and our desire to keep databases small and keep the chatter down. Um,
The moment that you say, I switch the intervention to another one who's responsible, automatically Jinaga will say you can have two people who are responsible.
yeah,
And later you can merge them, but at any time you can have two, three, four people.
yeah,
Um,
yeah. Which I think I think guides you to a slightly different presentation of that. So you talked about once you open it, then you own it, which you said makes people a little bit fearful of opening it because they don't want to take it over. But I think that kind of guides you to a very deliberate action of okay, I can open this, I can explore it, and all of the action buttons for making changes to this intervention are disabled. But there's one button that's enabled that says I want to be the owner. Um, uh, and it kind of guides you there because in order to recognize that there are two owners, you would have to have some kind of presentation to the user, and then you would have to have some deliberate action for saying, okay, no, let's resolve this. I truly am the owner, or nope, let the other person be the owner, and those would be deliberate action buttons. So, yeah, so I think the ideas kind of permeate into the user interface, how we actually present these things, and how the user interacts with it.
Because even if the new owner says, I want to be the owner, there is still a moment that information is not synchronized
Yep.
or not replicated.
Yep. And the other person could say, I want to be the owner. And so now you're
Yeah.
right back. It's like, okay, introduce these two facts. And when I resolve that graph, you still have two leaves. Yeah. Yeah, it's the same thing that happens with the mutable property pattern that actually shows itself on the user interface. So so you have two people change a name or a phone number or some mutable property of a thing, and now you've got two different possible versions of it, and so the user interface shows you one of them, and then also shows you that there's that there's a conflict, a non-conflict conflict, a
An alternative.
yeah, there you go, an alternative, and then you pick that and you say, okay, these are all the candidates.
There
That's
is a
the correct
parallel
one.
world.
Yeah, yeah. There's another Spider-Man over there. Yeah.
Is that something they ran into, or they had to adapt a user interface for that?
That's not something that that this team has built into their application, and so they are relying upon the fact that that an order isn't sent. It doesn't leave this device until somebody hits the submit
Okay.
button, um, and so they're relying upon topology in order to solve a consistency problem. But and for the most part that'll be okay. But Jinaga still doesn't allow you to say that there is one and only one version of the property. You run a query, you're going to get back a collection. You're not going to get back a single value. And so they simply use .first or first or default in order to implement their conflict resolution, and that's just on display, which means that it's possible if somehow an order gets onto two devices for you to see a different version on each device, because that one thinks it's first and this one thinks the other one is first, because these are sets, not lists. So first has no meaning. Um, so um, so it's possible to get incorrect or confusing behavior out of the user interface if you do something that is not yeah not not recommended. So yeah, I guess that is one of those cases where I was incorrect. It doesn't prevent you. The library doesn't prevent you from doing that. It returns a collection, and collection have .first or default on them.
Yeah. Because so they wait until the the whole record is complete.
Mm-hmm.
Then they push it to the replicator.
Yeah.
But you can get into the same trouble if you allow them to edit the record afterwards. So, for example, they add a new customer, Once all the customer data is there, they say, okay, go to the replicator. So now it can be on multiple devices.
Mm-hmm.
And then on both devices, somebody starts to edit the last name of the customer. So then
Yeah.
it's branching off again.
Yeah. And in this particular case, they have decided to solve that in the user interface. So it's stacking all of these decisions on top of a consistency problem. So they've decided that once you've hit that button, then it is hidden from you. What they really want is it for not to be on this device at all, but what they can get is a where not exists clause. So where not exists, order submitted. So you hit that button, and now your list of orders doesn't show it, and therefore you can't select it to edit it.
So there is no editing possible.
Right. So if there's a problem, you call the central office and you say, "Did that order that is submitted? Let's fix that problem." So
Okay.
yeah. So that's so far I've been taking the side of the client, say, okay, this is what the decisions the client wants to make. Now I'm jumping back over here, and I said that's a poor user experience. We can do better, and we have the tools to do better. So yeah, I think we're still in that phase of they don't trust Jinaga. Why? How could they? and so they're trying to solve consistency problems, and they're doing that through their use of technology, their use of topology. Which thing happens where, the use of user interface and process, and it's like, okay, is it going to take some time? But let's let those things go and instead rethink in terms of historical modeling, in terms of historical events and partial order and eventual consistency.
They are losing another big benefit, which is somebody starts on his, for example, on his telephone, and afterwards you want to finish the order on your computer.
Mm-hmm.
It's not possible because you have to finish it where you started it before you can submit it.
Yeah, that's true. Yeah, you should. I would believe that you would want to have all of the orders synchronizing as you're editing, so that any device can see these are the orders that I'm currently taking in this store. So if I need to pick up an order, I don't need to pick up the exact device that somebody started on. I could say, all right, I'm on this device, and boom, that same order is here too.
And you're sure that your data is safe, because as long as it's on one device.
Yeah, then it's not going to get lost. Yeah, but that then means that okay, an order can be open at the same time on two devices in the same store. So now you have to present the user interface for these alternatives. So okay, that now becomes part of the user experience, and users are not used to that user experience. Users expect there to be one value for every property.
Not yet.
Mm-hmm. Yeah. So there's got to be education, if not on the developer side, more on the developer side for sure, but then also on the user side.
Mm-hmm. No, but that means that your team is really aware of the problems. The fact that they say we have that submit button, and they don't make the mistakes that I made in that 2004 software. They know that there is a problem, so they avoid that problem by topology. But eventually they will see that Jinaga offers the solution. But we have to come up with user interfaces which support that.
Yep. I have a solution. It's just not a solution you like. So, okay. Well, I'll wait until you like it, and then you can start using it. Yep. That's I think the path forward. I've seen so many projects that try to implement the solutions that people like. Try to implement the promises, and not realize the limitations of distributed systems,
Mm.
and so therefore they make promises they can't keep.
Yeah. Yeah, there is education to be done.
Mm-hmm. Excellent. Well, yeah. So I guess saving news to the very end here. Next Wednesday, I'm going to be doing a talk with Improving Talks. Um, so we're going to be we have started an application modernization series
Mm.
with Improving Talks. So next Wednesday is the talk where I talk about modeling in order to gain business insight. Uh, so not specifically modeling for implementing software. Um, so uh, so when I told you earlier about hey, I've got this talk coming up on
Mm.
historical modeling and I want to be able to use these models. Originally it was just a historical modeling talk, and then as we started to design the series, it's like, you know what, uh, this should bring in several different modeling techniques. So we're going to be talking about domain-driven design, event storming, and historical modeling, and focusing on how you can gain business insight from those three modeling techniques, not focus on uh, the implementation side of them.
Okay.
So that is
Mm.
coming up. So I'll drop a link to that page um,
Yep.
in the
Is
general
that
channel.
Yeah, that talk will be recorded,
It will, yes,
or okay,
yes.
but it will be not be live streamed, I assume.
It will be live streamed as well
Okay,
at 1800, so 4 hours
okay.
from our usual start time for this.
Hmm.
Um, so yeah, that'll be on Wednesday.
Okay. That link you will put in the. All
Yeah,
right.
yeah. I'll put that in general, and I'll send it to you via email as well.
Okay.
Yeah.
Great. Then I can follow that. Good. How is the book
All
in the
right.
meanwhile?
Oh yes. So I just yesterday received the final review. What do we? There's a term that they use for it. Yeah, I can't remember what it is, but yeah, the clock starts now for I've got 5 days to read the book again, look for uh, typographical errors, that kind of thing. No content changes at this point, just
Mm.
fixes, and then they start the production process. Um, so this is a little bit earlier than we originally thought. So originally we were saying it's going to be in June. This might mean that last week of May is when it will be available. So
All the better. All the better.
yes, indeed. Yeah. So perfect timing for the talk. So I'm going to splash the second edition cover up there, saying this one's coming soon, which works really nicely
Mm.
because there's a book about domain-driven design. There's a book about event storming. And so it's like, here's the book, here's the author, here's the thing.
Mm.
Oh, that's me. Wow. Who knew?
Mm. That's good news. The more people we can get do that,
Mm-hmm.
and especially now the fact that it is used in production or will be used
Yes.
soon in production, um, because it's amazing the number of problems that come up and the number of scenarios,
Yeah.
um, but fundamentally nothing changes.
Mm-hmm. Yeah. And now I have a prioritized backlog. So the things that I didn't get to during this process, by the time August rolls around, those will be
Mm.
done. So when we say, okay, now we really need on-device encryption. All right, it's already implemented now. Um, yeah, one of the other things you would need to be able to create a user principal on device temporarily in order to um, to implement one of the patterns, the application patterns in the book. It requires you to create a user principal that's not you, assign administrative privileges to a thing, and then forget that user principal. Um, so,
Hmm.
so yeah, that'll be in the library by then as well. So you'll be able to
Was
do all the things.
that was to share information in a group.
Yes,
No, yeah.
yes, without having one person be a privileged
Mm,
member of that group. It's like that was the
mhm.
creator, and they can no longer be revoked. It's like nope. The creator was a temporary user principal. Everybody's the same. Everybody's an administrator.
Mm.
All privileges can be revoked.
Okay,
Yeah.
that's nice to hear that there is a lot of progress.
Yeah. Yep. Yep. So I'm pretty happy with that. Um, yeah. So I guess next week we're back at our regular time, regular schedule. And maybe we can start talking about the DWS model and getting that implemented.
Yeah, because I have to start with that also.
Mm-hmm.
Yeah. Um, Good. Then I see the link for Wednesday, and on Thursday we will be back and start again with DBS.
Yep.
All
All right.
right, Michael. See you on Wednesday then.
Yes, indeed. See you then.
Okay. Bye bye.
Bye.